Hi, and welcome to Statistics 1, Lab 3. The goals for this week's lab are, first we'll read a data file into R and print summary statistics, just as we did last week in Lab 2. But since one of the main topics this week is correlation, we will run a bunch of correlation analyses in R, and we'll examine relationships among variables using scatterplots and scatterplot matrices. So you'll see for this lab that I'm using the same data set that I used for lab 2. That will keep things simple, and hopefully this lab will be a little shorter than last week as a result. So again, it's the example investigating the effects of sports-related concussion using this online assessment tool called Impact. The one change I made to the data set is I gave the variable names sort of shorter labels. You'll see that comes in handy when we're looking at the correlation matrices and the scatterplot matrices. So again, at the beginning, you should always make sure you're in the right working directory. So you can use getwd for get your working directory or setwd for set your working directory. I have all these commented out because I have that done already. And again, you might have to install some new packages for this lab, particularly gclus and rgl. So I already did that. I don't want to waste the time in lab to do that, but you might want to pause and install those packages, gclus and rgl. Okay, of course you still need to load those packages, so I still need to do that. I'll load the packages and I'll read the data into a data frame called impact. And I didn't get any errors, so that looks good. I might want to view the data or edit the data just to make sure it's there. You can use this view function, but I know that it doesn't work on all operating systems, so try it. But if it doesn't work, you can use edit. That should work in any any machine, any operating system. So here you see the data. It looks just like last week. We have a bunch of athletes who are in a control condition, a bunch of athletes who are in a concussed condition. We have verbal memory, and this is at time 1 or baseline, visual memory, visual motor speed, reaction time, impulse control, total symptom score, and then all those measures again at time 2 or retest. Again, for the controls, that's just test, retest. So you'll see that we can use those as sort of to get estimates of reliability. And of course, the main purpose of this type of research would be to look in the concussed group and see what happens as you go from time 1, baseline, to the tests after an injury. Okay, so let's go back to the script. Just as we did last week, we could just print some summary statistics just to make sure we have the data we think we have, and there we go. I do the describe function on the impact data frame, and I have 40 subjects or 40 athletes in this data file, and there's all my variables and summary statistics. Okay, this is sort of what we covered last week. But again, we'll do this probably every lab just to reinforce these basic concepts. And again, we could look at the summary statistics by condition. So if I use the function describe by the data frame impact, then impact by condition, then I'll get all my summary statistics for the concussed group and the control group separately. Okay, now let's get to the main topic of this week, correlation analyses. So the main function is just core, and what I'm going to do in this first analysis is just look at the correlations among all the baseline measures. So what I'm going to put into R is core impact open brackets 3:8, and that's because the baseline measures are in columns 3 to 8 in the data frame. Remember, columns 1 and 2 were subject number and condition. So the actual variables that we want to correlate don't start until column 3. So let's just do that. And here we go. We have a correlation matrix. And this first number here, this shows us the correlation, or little r, which we talked about in lecture, between verbal memory at baseline and visual memory at baseline. So it's about 0.38. So it's a little bit low. I would expect it to be a little higher than that, but it's positive, so that that suggests that verbal memory and visual memory, as assessed online via impact, has some reliability, right? Because if it didn't have any reliability, it wouldn't be able to correlate with anything. And two, it has some validity because it's showing convergence with another memory measure. Of course, it could be a little better. And again, the sample size here is a little low. We'd probably want a little more, some more athletes, but I just want to use the same data set that we used last week. So let's go back to the script. That correlation matrix looked a little noisy because there were so many decimal places. So let me just use this round function. It's sort of standard to look at correlations just to 2 decimal places. So I'm just going to round to 2 decimal places. And now, let me bring that up a little. Here's my correlation matrix. Now it's a little bit easier to read. So here's that 0.38. And notice that visual motor speed doesn't really correlate with verbal memory, but it does with visual memory. So that makes sense because it's visual motor speed. Also notice that it's negative. And that's because this speed measure was measured in reaction time. So if you have better memory, you're scoring higher on the memory test. But if you're faster, meaning if you're better at that task, then you have a lower value because it's speed. And that's why there's a negative correlation there. Okay, now we're going to create 2 subsets, one for the control group and one for the concussed group, so that we can do correlation analyses within those groups. So again, I'm going to use the subset function on impact. And if impact, if the second column, if the value in there equals control, I'll set that athlete or that row into the control data frame, and same with concussed. And there they are. Okay, so now let's do a correlation analysis of the control group, all of the measures. So this is both baseline and retest. So here's this nice big correlation matrix. It's a 12 by 12. And again, one thing I maybe should have pointed out to you if you're new to correlation matrices is the diagonal is always going to be 1s, right? Because that's each variable correlated with itself. And this matrix, every correlation matrix, is symmetrical. So the values below the diagonal are the same as the values above the diagonal. So here's this correlation between verbal memory and visual memory. Now we're getting a nice, strong, positive correlation. But what I mean by symmetrical is you see 0.69 here, it's also up here. And negative 27's here, negative 27's here. So you only have to look really below the diagonal to look at all the correlations. But what's interesting in this data frame in particular is these are the control subjects. So they just performed this assessment tool at baseline and then sometime later at retest. So if we look at the correlation between verbal memory at time 1 and verbal memory at time 2, we could think of that as a test-retest reliability estimate. So it's 0.67, which is, okay, it's not bad. The visual memory is a little bit better. Visual motor speed is not as great. And then look at this one. The reaction time measure, it's remarkable. It's rare that you get exactly 0. The reaction time measure does not look reliable at all. Right? Impulse control, really good. And total symptom score, not bad. So these reliability estimates are, for the most part, good, except for this guy. But remember, there's only 20 athletes in the control group, so there might be some sampling error. So I don't want to make any strong claims about that website impact based on these 20 subjects or 20 athletes, right? This is just to illustrate the idea of correlations and the idea of test-retest reliability. So now let's look at the concussed athletes. If we look at the concussed athletes, all the measures, again, I get a 12 by 12 matrix. All the diagonals are 1s. It's symmetrical. Now, we can't really think of these as test-retest reliability estimates because they were concussed in between. So some of them are still high, but it's hard to know, what those correlations mean. I just wanted to run it so we could see the same thing that we saw for the control group. So let's go back to the script. So beyond correlations of just the main measures, I thought we could do something a little bit more than that. And this will also prepare you for the next assignment, because we'll ask you to do things like this in the next assignment. So let's propose a question. Say, does the baseline impulse control of an athlete predict their memory impairment after a concussion? So maybe athletes who are more impulsive are going to engage in a more aggressive style of play, make themselves more susceptible to sort of more dangerous plays and sort of maybe more severe concussions, which might then result in a worse overall memory impairment. Again, I'm sort of making this up just for the lab so that we can do some more with the data than just look at correlations among the measures that were provided. So the first thing we need to do is let's just get a composite measure of memory impairment. So we'll combine verbal and visual. So first what I'm going to do is in the concuss group, I'm going to create a new variable called verbal impair for verbal memory impairment. And I'm just going to get that by taking their verbal memory score at baseline and subtracting their verbal memory score after an injury. Then I'll do the same thing for visual memory, and then I'll combine those by averaging them to get an overall measure of memory impairment called memory impair by adding those two impairment measures and dividing by 2. That just gives me the average, or a composite measure of memory impairment. Then what I'll do is I'll correlate that measure, that new variable that we created, with impulse control at time 1. And let's see what happens. We get a correlation of about 0.229 or 0.23. So there's a slight positive correlation. It's not that strong, but it does look like there's some relationship, perhaps. Again, the sample size is a little small, but it does suggest that those with sort of higher scores on impulse control show greater memory impairment. Again, but that correlation's a little bit low. You might want to know, is that correlation significant, like statistically significant? And that's exactly what we'll cover next week. So in next week's lectures, you can start to think about whether certain correlations are statistically significant or not. It depends on the sample size, and it depends on the variability. And you'll see that in next week's lecture and next week's lab. Okay, so now let's go to scatterplots. And this is the way to visualize our correlations or visualize relationships among variables. And I put in a note here, there are a lot of scatterplot functions and they're in lots of different packages. I tried to keep this simple so that we wouldn't have to download too many packages. But you'll see there's a lot of fun things you can do with scatterplots, and there's a lot of advanced options. So feel free to explore around, and if you find some interesting things, feel free to share them in the discussion forums. But let's start with the most basic plot. It's just a plot function. And I'm just going to plot verbal memory and visual memory at time 1 because those showed that positive correlation. And here's the scatter plot. Let me make it a little bigger. So here's visual memory on the x-axis and verbal memory on the y-axis. And if you eyeball it, it looks like overall there's a slight positive correlation. But we can do better than eyeball it. Let's put a line on that scatter plot called the regression line. Again, this is the topic for next week. And that'll characterize that relationship. Yep, I have to do the plot again. There we go. So now what the regression line is, and we'll talk about this in detail in lecture next week, and you'll do it again in lab next week. What this line does is it minimizes the distance between each dot and the line and that's called ordinary least squares regression, which we'll get into next week. It also allows me to predict scores on the y-axis based on scores on the x-axis. So if you get a really high score on visual memory, then I say like around 90 here, and I can go up to the regression line and then over, then I would predict you to get about almost a 95 on the verbal memory task. So that's what the regression line is used for. If you see it like this nice positive slope, that means there's a positive correlation. If it was completely flat, that means there'd be a correlation of 0. And if it was going the other way, a negative slope, that means there'd be a negative correlation. Okay, let's move on to scatterplot matrices. So we have a lot of measures in this data set, so I might want to visualize all the relationships at once in a matrix, just like we did with the correlation matrix, but now with scatterplots. So let me run this. And now I have what's called a scatterplot matrix. So you can see it's all my measures. Let me make it a little bigger. Okay. So I have verbal memory at time 1, visual memory at time 1, visual motor speed, reaction time, and symptoms. So here's that one scatter plot that we looked at between verbal memory and visual memory. But this shows me all of the relationships at baseline. One thing to notice is down here, symptom score, why are all these dots just sitting right on the bottom of the graph? Well, that's because it's symptom score at baseline. Most athletes are scoring 0. They're not showing any symptoms of a concussion because it's baseline and they're healthy. Okay, we can do, as I said, there's lots of things we could do. I'll show you 1 or 2 more fancy things. So I'm going to run this whole chunk of code and then I'll walk you through it. But what this will do is give us a scatterplot matrix that's colored, and it'll order the variables in the scatterplot by magnitude. So let's take a look. Check that out. It's very cool. Let me make it big. Okay, so again, this is just at baseline. So you saw that verbal memory and visual memory, those are the 2 strongest ones. So it puts those together with this sort of purple color because that's a stronger correlation. And then symptoms is way out here on the periphery because it doesn't correlate with anything at time 1 because there's no variance. Again, if you don't have variance, you can't get covariance. All right, so that's just sort of a neat thing you can do. Again, there are many other options. Feel free to play with or search around the internet for different options for scatterplot matrices. One more thing I want to do is show you scatterplots in 3D. So we could look at just the relationship between 2 variables like verbal memory and visual memory in a 2-dimensional scatterplot, and that's standard. But R has lots of advanced graphics, so why not take advantage of these 3-dimensional plots? So let's look at visual memory, verbal memory, and symptom score all at baseline, but in a 3-dimensional plot. And you'll see that this one is interactive. So see, it opens up. If I click on it and hold my mouse down, then I can move it around. And we can visualize 3-dimensional relationships. So if I hold it just like this, it looks just like the 2D scatterplot we just did. So visual memory on the x-axis, verbal memory on the y, but I can spin it, right? And if I spin it this way, I spin a little more, what you see is now going left to right here, you don't see any dots, right? They're all along the left. That's because, remember, symptom score, all the athletes are scoring around 0 at baseline. So that's why I started with this one, so you can sort of get a feel for it. And again, what I'm doing is I'm just holding down my mouse and I'm sort of dragging it around. So let's just do one more, and that'll be the end of this lab. So now let's do those same 3 measures, but at time 2, so that we don't have just all zeros for symptom score. So now again, let me just, here it is, that visual memory, verbal memory in 2D, but if I sort of drag it around, drag it this way, now you see in this other dimension, you see there are symptom scores sort of all over the place, because this is after concussion. So it's pretty cool. You can play around with that. You could add color. Again, you could add regression lines if you like. So feel free to play with that more. But this is about all you'll need for now to understand correlations and scatterplots and to do assignment 3. So good luck on that, and I will talk to you next week in Lab 4.